Hello guys and welcome back to the sim here in Brunei. Today I'm going to be building this 737 FMC. It's fully 3D printed. All it requires is a 7-inch LCD screen available from eBay and about 74 tactile LED switches. It really is quite a simple build, but it can be quite monotonous getting it all wired up. Now there's absolutely no PCB involved. If I turn this over, you will see that every single switch is hardwired to the Arduino. Now this is going to be a very in-depth video. Please feel free to click through and find the parts you need. I will try and timestamp each part to help you out. Let's crack on with the video. Now I've created two versions. We've got the full-size version in my hand here. This is for the CR10, so about a print bed of about 300mm square. And then for the smaller Ender 2s, or Ender 3s, with a print bed of about 225, I've split the design down into two sections, so you can print it in separate parts. And hopefully, when you join them together, it's in a place where you can't really see the join and it looks like one piece. That was the whole idea. On to the next part, and that's the backplate. Again, it's created in two parts. So there's three versions. There's the full-size version, which is for the CR10. Then there's the split-down version for the Ender 3, which is a slightly smaller print bed. The two parts screw together. We'll get to that in a minute. All these tactile buttons, we've got these ones here. That's what we're going to use. So these tiny tactile buttons have got a little LED in the middle. This is my prototyping board. It's the one that I used as to help design the buttons, and these tactile switches just push into this and you fold the legs over and it holds them in position. Of course, you've got the faceplate that actually holds them in so they can never fall out. And by using these tactile buttons, we're not going to use a PCB. So if you're looking for an FMC that has a PCB, I haven't got to that stage yet. I am going to sheer use brute force by just wiring every single switch together, so that the back of this board is going to be packed full of wires. It's a very simple design. We are going to use an Arduino Mega. We may even have to use two, because I reckon there's about 70 buttons on here and only 69 inputs on an Arduino Mega without using a multiplexer board. The next thing I want to show you before we go any further is all the different types of buttons I've created to try and find the best result for 3D printing. Now, there are four versions that I'll distribute in the design. That will be filament printed buttons with raised text, that's number one. Filament printed buttons with engraved text, which you can then wax and fill. Then I've got the resin printed buttons, and these are definitely the way ahead if you're going to do 3D printed, but of course not everybody's got a resin printer as well. However, the text is perfect. I'll show you that in a second. So the first version up is the dual printed layer button, where you swap the filament at the end. So they're printed with white, so it allows the LED to shine through, and then it's got a black top which highlights the letter, as you can see. Next up, we've got the resin printed raised text. These are probably the ones I'm going to use today. They're printed in white resin to allow the LED to shine through. We're going to spray them black in a minute and then sand them off. And you can see the letter E here has turned out really well and actually backlights really well as well. And the final version is the resin printed in black PLA with wax infill. And these look absolutely amazing. So before we go any further, before I decide which buttons we're going to use for the FMC, I've got the raised text with sanded ring on my left, and we've got the engraved version on my right. So these tactile switches have got bases, and they also have little clips printed into them to stop the switches from falling out. All you're going to do is push them in. There you go, you heard it click in. So first up, we've got the engraved text, and you can see that actually looks really good. Highlights it really well. Let's put the Now the wax head on. Wax infill, I've used the wrong kind of black PLA. It's kind of transparent PLA rather than black PLA, so it doesn't stop the light from coming out at all. So for this example, I'm going to use the resin printed embossed version. I'm going to grab my paint stick, put some masking tape down so we can stick the buttons to it, ready for painting. Secure it at both ends. And now it's just a case of putting all these embossed text onto this piece, ready for painting. I'm just using this standard spray paint. It's matte black and a couple of coats, and it really sticks well to PLA, either resin or filament. It's cheap as well, which is always a bonus. Let's head outside and do some painting. I've come back inside because here we've got the faceplate, and as you can see, there's a bit of stringing happening between the button holes. That all needs to be cleared out. So let me crack on with that. So I just having to move some of the support material from where the screen sits. All the buttons are dry, at least I think they are. They've been out there for a couple of hours. I'm going to get my small mini file and I'm going to try and gently take off the top layer without damaging the rest of the button. And hopefully I'm just going to run the file across the top and take the paint off. And there we have it. First letter done, another 67 to go. Now it's time to start populating the backboard with all the components. Got my LED tester here because I do not want to put a duff LED into this unit, put it all together and realise I've got a bad one at the end. That's happened so many times before. So we've got a green LED, that's going to go in the top hole. Okay, that fits in nice. Going to bend the legs over to hold it in place. That's nice and secure. Red is on the left. Yep. It's one in. That works, so that can go in. Split those legs. I'm going to grab my faceplate because this is actually the first time I have tested the fit of the LEDs into the unit, and once again I probably can see that there's a bit of a lip on this LED's hole, so I'm just going to use the chisel here just to cut it out. Oh wow, that's pretty good. They're tight, don't get me wrong, there is a bit of force, and if I try and pull these back off now, oh no, I was expecting the LEDs to try and get pulled out. That's good, so the LEDs are in. Next is our 10K pot. Yeah. Hopefully you'll see there is a locating hole for the locating tang on the pot, so it can only go in one position and it holds it securely. Flip the unit over and hopefully attach the nut. Give that a good tweak. And once again, because I've never actually tried the fit, I need to put this back on and make sure that they go together without any fouling, and they do. That looks really cool. And I can't resist. It's not that one. Let me just search through these parts here for the good one. Is the dimmer knob. Of course, I've not tried that fit either, and oh, that works well. So we need to create the buttons first, and I've got a big pot of white LEDs here. LED tactile switches, should I say. So you can see the red leg painted there. That's the cathode, and you can also hopefully see the lip that locks into the buttons at the top on the white section here. So we've got our upper buttons, and these are the white bases. These will click onto the tactile buttons. So the idea is to push one side of the button in, use a small screwdriver, and then just push the tab in, and that works. I'm trying not to bend the legs too much when I'm holding them, which is a bit of a downside. And then we've got our black button caps to go on the end. That is hopefully going to push on there. I've applied a bit of super glue. We're going to push the button cap on. One down. We need 12 of these. These should light up quite well when that's the general idea of making them in two parts. And I may have forgotten to mention that if you are going to make this design, print the parts, just print one base first, print the cap, just one of each, and make sure everything fits together when it comes off your printer. These were all designed for the Ender 3 and the CR10, so they work really well. However, every printer will be different, and the tolerances are minute. We are talking about 0.1 of a millimeter here. Let's see what these look like. And once again, you really want to make sure that all the red legs, the cathodes for me, I'm going to have them all facing up. So it makes it a lot easier when I come to wire them. Now you're just going to bend the legs over to hold it in place. There are our upper action buttons all done. Now we've got the large action buttons in the middle here. It's exactly the same process. We've got our base. Our LED clips in. We just squeeze the tongues together, slide it in, and that way it should be permanently attached. Make sure it operates. I've got a few of these to do. I'll catch up with you in a minute. So the letter bases, they're a bit bigger, so they're easy to fit. Just compress the tongue, slide it in and push it from the back. Make sure it clicks. Job done. I've just finished creating all the buttons. I've got sore fingertips. Let's start to install these. I actually need my phone out of my pocket because I need to see what buttons go where. Let's have a look. So into Google. Let's type 737 FMC. Ding ding ding. And let's see if we can find a good image that I can copy. Let's just hope it's the right one with all the buttons in the right place. Okay, so init ref is the top left. I'm going to bend the legs over to the outside. Now if you're wondering why I'm bending them on the outside instead of bending them in, like you probably expect, it's because they actually touch each other because they're that long. So you're going to bend them out, and there we have the init ref button. Oh, that's better. It looked a bit ski-whiff for a second there. Let me put this on time lapse because this is going to be very boring as I fit about 62 buttons to this following this procedure. I'll get back to you in a mo. That was actually quite a bit of a slog to put all them in there. It's taken about 27 minutes according to the camera timer. But they're there, they're secure. And it's now a moment of truth where we put the cover on and see if it all fits together. Here we go. That was a good positive click, so was that. Okay, so I'm just running through, checking everything works, and then you realise you've cocked up. Because even though I've pushed it all together, and that took a little bit of effort, there we go, I've forgotten to put the LCD screen in. Oh dear. So I really am hoping that I can now slide this in. I'm going to take the protective screen off finally. Well, I was going to try and take it off, but oh no. Okay, so that's not good. What's happened there is that plastic has been on the LCD screen way too long and it's really stuck to it, and it's left now a sticky residue that I need to remove. You might just be able to make out here the bits of adhesive that are coming off in little round balls. Okay, screen looks okay, it's not perfect. So I've got to put the tab towards the bottom. I actually think the screen might be upside down, but that's okay because you can always change the orientation. And we'll see if we can slide the screen in now. Hopefully without too much pressure. There we go. Let's see if we can get this to go back together. Turn it over and gently get some screws in. Okay, so I'm going to do a 100% button check now, and that's to make sure that each button isn't stuck and it operates nice and cleanly. So how cool does that look? It's turned out really well. We are missing the M button because apparently the M didn't exist in the alphabet when I was doing the design. I can't understand how that hasn't printed out, but we are definitely missing the M button. On goes the 3D printed dimmer knob. So next up, this is the translucent green annunciator lens, and we're going to install that in the top hole. Oh no, so that's a little bit too loose. Can I get it back out? I can. Little help of super glue. Just a dab, and hopefully. Next up, we've got the right annunciator, and all it is again is translucent clear filament with raised text. It's sprayed black and the top is then sanded off to reveal the text. I'm going to put that into the hole on the right hand side. Oh, that's a nice tight fit, and the same with the left hand side annunciator. That is a loose fit, even though they should be the same dimensions. Oh, it's not quite that loose, but a bit of super glue just to nail it in there. So next up, we've got the power pack. We're going to test the LEDs to see what they look like. Let me turn some of these studio lights down so we get a good look. Hopefully you can see now, guys, from those quick tests of the Liteflow buttons that you can achieve backflow lighting with resin and filament printed parts. Of course, they're not going to be anywhere near as good as laser etch parts, but they're good enough for a homemade project. Hopefully, once we get this all wired up, it's going to look absolutely stunning at night. Now I'm going to flip it over and install the interface boards on the back. The final job before we start the wiring. Here's the main board, and that's just going to go over the edge like this. Then we've got the menu board. Now this was kind of designed to go across the board. Before I go any further, I want to insert the LCD ribbon cable before I forget it. So that should just slide in like so, and then we just close the little clamp on the connector to hold it in place. I like how it's actually held in a down position as well. There's our LED. What's next? Ah, it's the Arduino mount. Now you can see I've had to remove the back of the VGA connector because I do not want that in. I'm going to feed the VGA connector across the bottom of the board and then hopefully slide this into position. Use the two studs that held the connector together to hold the connector into the board. There's our VGA connector and then our power plug should just slide into this receptacle there. And that leaves the whole area now clear for soldering. Our Arduino board will go on last, and that goes in there like so. So we've got our VGA, our power plug, and our USB. With the unit proven, it's now time to connect all the wires up. This is going to take a while. I can imagine a few time lapses coming in here, and it's going to look a bit messy until we get a PCB made. That's later on though. As I said, we're going to brute force it and see what we can achieve. Cool, that's how we're going to proceed. I'm going to repeat that procedure now for all 70 buttons. I'll get back to you in a minute. That's the Arduino fully wired up. All 69 pins are fully populated. That includes the 16 analog pins. Still not enough, and I always knew that. So rather than fit a second Arduino and waste all the excess pins, because we only need 6 more pins, 7 if you include the excess ground, to transfer it to another Arduino. So we need 7 more pins, plus I've got the 2 backlighting lines here. These are 12 volt. So I need a further 2 for them. Luckily enough, I was told last night that the pot on the front here is for contrast, screen contrast, and not for backlighting control. The backlighting control comes from the pedestal dimming knob, so I don't need to wire that up at the moment. And that's why these two 12 volt lines need a separate dedicated line out to the pedestal to be powered by the pedestal backlighting. To cover the 7 extra pins that I require, I'm going to use these HX connectors and then take them out to another Arduino via a small wiring loom. Let's get these mounted and they'll probably become a bit more obvious. So what we've done here is we've put 7 extra pins in. 6 pins will be for the extra buttons required on another Arduino, and the last pin, pin 7, will be the common ground. At the top we've got the 2 extra pins here, and they'll be for the 12 volt backlighting fed from the pedestal panel. Next up, I'm going to mark the ground pin for the 12 volt lighting, because I do not want to put 12 volts in the wrong way and damage the LEDs. It's finally time to plug this thing in, get it programmed and get it working. I've got the USB cable, VGA cable, Arduino transfer cables, 12 volt power cable. I've already programmed the devices to the MobiFlight boards, and we can check that by going into extras, settings, MobiFlight modules. There's our 2 Arduinos. The bottom one with all the buttons is the card attached to the back of the FMC, and the top Mobi Flight board is the auxiliary one that has the 6 excess buttons attached to it via the extension cable, and that just got aux2 to aux7, their buttons, and they're all buttons apart from pins 9 to 13, which are the 5 LEDs for the indicators. On the left hand side you can see that I've got an Excel sheet. Now I use these, I usually print them out and write down in the boxes what each pin does by going to the debug and looking at the bottom. So if you look at the bottom of the screen here, it's debugging away there, and if I push a button it will tell me what button's pushed and what pin that's attached to. All I have to do then is when I push it, where you can see that button 42 is the action key on the left hand side. So button 42 I've written in is the action key left hand side number 1. I now need to do that for the LEDs. So we're going to create a test line in the outputs tab, hit edit, display, module, the second one, pin, here we go, that's correct. Output 9 is an LED, and then hit test, and it's message indicator. Message, stop that, go to 10, that's the offset indicator. $11 is the display indicator. $12, hit test. That's the execute indicator. And hopefully that just leaves one more. I've got to push test first, and that's the fail indicator. And there we have all 74 pins mapped out over the 2 devices. Open ProSim server. Yeah, use evaluation, accept, nope. Okay, so we've got ProSim loaded up. So I'll be using FSU IPC to interface between Mobi Flight, ProSim and the sim. This is the same for X-Plane, Microsoft Flight Simulator and P3D. So I need to enable FSU IPC support. Hit OK. It may restart, it will do. It's going to load in all the FSU IPC drivers now. Oh, yes it has. Computer's just a bit slow. My bad. Here we go. Let's load it back up. So the FSU IPC drivers should now be installed. Here we go. Let's click it off to the side. No, I don't want to update. Okay, so we're going to go into config, configuration, combine config, into navigation. It'll be switches. Let me drag this to the side and blow it up. Right, obviously there's 277 switches to load up, so it takes a while. And what we're going to do now is use the free offset table supplied by FSU IPC and list the offsets for each switch. So each offset has 8 bits, which means we can control 8 switches with 1 byte. So I'm looking here at CDU1 key, which just means captains. CDU1 is the captains, key 0 pushed. I'm going to go to FSU IPC 8-bit, 8 bits obviously in that byte, and I'm going to label that 66D0.0. Then I'm going to copy and paste the 66D0 so I don't have to keep writing it in, and then misalign because it's now key 1 pushed. This is just for speed because I've done this quite a few times in the past. And we're only looking for the pushed keys, and I'm increasing by 1 each time from 0. All the way up to 7. Now we can't use that offset. We've fully used all the bits in the byte. Make sure I get it the right way around. So now it's going to be 66D1.0. Highlight that and copy it. And that's going to be 1. And now it's just a process of repeating this through the offset range until all 70 keys have got their own individual offset. So you can imagine this is going to take a little time, and cue time lapse. That's all the offsets entered. So each switch, each button has its own individual bit, and we used 10 bytes of 8 bits. So quite a few. Not on the last byte, we only used the 0 section of the bit. So all the way to the top. Now they've all got their offsets assigned, we need to copy those offsets into our Excel. Then we can take those offsets from Excel and program MobiFlight. You could just program MobiFlight direct by having that open, but it's always good to have a record for yourself of what offset is used for which button. Back to time lapse. This is going to take a while. So we're starting with pin 3, and that is 66D0.3. I've entered all the data for the switches. That leaves the 5 LED offsets that we need to enter. And I believe, do you know what? It was D9.0, wasn't it? I'm sure. Let me go back into the config page of the switches, find the last offset I used, which I'm sure is D9.0. And then we'll continue using the D9 offset for the LEDs. There we go. So we use the hex code 66D9.0 was indeed the last one. So we can use D9.1 for the LED. So indicators, here we are, CDU. I've entered our offset values for the LEDs, just got to transfer them across now. So message is 66D9. Did I get that right? 0.3, yeah. Then we've got offset, which is 66D9.4. Display, which I'm going to guess is cool, 66D9.5. Execute is D9.1, 66D9.1. And fail, 66D9.2. I can finally close down the config page of ProSim. Now let's start with the MobiFlight. Okay, let's start programming MobiFlight. We can use the first line. We're in the Outputs tab. So let me move this to the left, make it big. There we go. And we're going to do the LEDs first, and this is going to be CDU1 message. Edit the line. And this is where the offset's important. Message is going to be 66D9.3. Oh no, it's not. D9. D9 only, I always forget that. Then in the mask value, we select the 0.3. So that is the bit in the byte that we're going to use. It's a 1 or a 0, so 1 being on, 0 being off. And we're only using bit 3, so it's only looking for that 1 or 0 in that bit, in that byte. The bit in the byte. Hit OK. The most important thing you need to know about the offsets in ProSim and MobiFlight is they must match. So whatever value you use, as long as that value is the same in ProSim as it is in MobiFlight, it should work. If you accidentally use an offset that is already used by something else, that's when you get problems. And say if you turn on a switch there, it will turn on a light over there as well. Cross-mogination. so important to be slow and methodical when you enter these values to stop that fault finding later on, because it can take quite a while. Anyway, back to programming MobiFlight. We are using FSU IPC value, and message is pin 9. Once we've entered that first line, now all we can do is duplicate the line and just edit the data. So it's not going to be message, it's going to be offset. Edit the line. Offset is pin 10. And the value is D9.4. We go to the mask and we change the 4. We take off the 3 and hit OK. You do not leave both of them connected, or once again, you're going to get strange things happening. Hit OK. And then just keep repeating until it's all done. Edit the line. So my next one is display, DSPY. It's going to be pin 11. Hit OK. Oh, I didn't want to do that. And then edit the sim variable. Display is pin 5, byte 5, bit 5. God damn it. Display is bit 5. Hit OK. That's it done. Duplicate line. Next one is execute. That's not how you spell it. There we go. This offset value is D9.1, so it's completely different. Take the 5 off, put the 1 on. Display is 12. And we're going to duplicate the last row, which is fail. Hopefully not today. Edit the line. It's going to be pin 13. Sim variable. And fail is 0.2. There we go. Hit OK. OK. Those 5 lines there are now, I'm going to make them active. They're ready to be used. Now to the inputs. All 69 inputs need to be inputted. Again, it's a bit of a slog, but it has to be done. And we're going to start off with, I was going to run straight down the list to make it quicker. CDU1. We're going to go into the edit line. The module will be the second one, and it's going to be button 2, button 2. It's going to be FSU IPC offset. And I'm just going to type in 66D0. The mask value will be 0.0. Yeah, OK. And set value 1 when pushed. Now this part's very important. Do not forget the on release tab. So once you release the switch, you need to duplicate the data. So it's now 66D0 and it's 0.3. Hit OK. I just need to make sure that 66D0 and the hex code 08 is the same, and it's not, so I've gone wrong somewhere. D0.3, that's what I thought. Oh, that was good. D0.3. So now the 08, 08 and 08 match, and the set value will be 0. So when we release the switch, it tells the program to put a 0 in. And now it's duplicate the other 68 keys. As you can imagine, even duplicating, this is going to take a while. Q, edit it. It's now going to be button 3, and the offset is D7.3. That's okay. D7, D7, button 3, button 3. Okay. Duplicate. I think you get the idea. This is pin S now. Button 4, edit the line. It is D7 and this time it's 0.6. All I got to do is change the 3 to a 6. On release, change the 3 to a 6. Okay, and hit OK. First 3 buttons done. Guys, I'm not going to bore you with the rest of them. It's just a simple fact of duplicating the line, changing the values and doing it for the other 67 values. I'll catch you in a bit. I believe that's it all programmed. You can see this enormous list. There we go. Everything's activated. It's now time to hit run. With all the software working on the laptop, let's head over to the CDU and have a play. See if all that hard work has paid off. Okay, so this is the front screen of the FMC. Let's go into the main tab. And I'm just going to check for aircraft failures. There aren't any at the moment, which means the FMC should be fully working. Into menu, FMC, and we've got ident. All the position info looks good. Okay, so we're at Heathrow Airport, and that's Echo Golf Lima Lima. That went in. We're not at a gate, we're stood on the end of the runway. Go for a cost index of 5 today. Cruise altitude, flight level 310. I'm going to hit the execute. M1 limits. Outside air temperature of +14. Takeoff. We'll go flaps 5. C of G of 13.1, V1, VR and V2. And you may have noticed that now none of the buttons work, and that's because ProSim server has timed out. I've reached my 30-minute evaluation period. I actually do own a full copy of ProSim. It's on my main computer and not on my laptop. Guys, I think that's a good time to call this an end. It's been an exceptionally long video. I've tried to put as much detail into this video to try and help you guys get to this stage. It's absolutely awesome and I love how it looks. It's turned out really well for a 3D printed project. So if you're interested in building this, head over to the website www.737DIY-sim and download the files. Until next time guys, catch you later, sim out.